Everyone. Good morning to one and all. This is Guru Brahma, having 20 years of experience in teaching. In this session, we are going to learn about thermodynamics and the two first law of thermodynamics. So before learning first law of thermodynamics, first of all, we have to learn about what is meant by internal energy. Internal energy of a system. So what is meant by internal energy of a? So it is the sum of all the types of potential and kinetic energies of constituent particles of given substance. For example, there is a system. For example, let us take there is a gas enclosed in a cylinder. Gas enclosed in a cylinder. So gas is composed of gas molecules. These gas molecules move. They possess some kinetic energy. As they are moving randomly very fastly, they possess mostly kinetic energy. The molecules which are moving very slowly will possess potential energy also. So whatever the types of energies possessed by the gas molecules, that comes under internal energy. So for example, whatever the substance you take, all the types of energies possessed by the particles of that substance is called as what? Internal energy. Internal energy is represented by E or U. E or U. So internal energy, both some books write E, some books write U. Internal energy can be represented by E or U. So internal energy can be chemical energy, electrical energy, mechanical energy, or other types of energies. So already it is mentioned that the different types of energies possessed by the body, or the different types of energies possessed by the particles of a particular substance is called as internal energy. So this internal energy will change when heat passes into or out of the system. So let us take this gas enclosed in a cylinder is system. This is a system. So when heat enters into the system, internal energy changes. May change when heat goes out from the system, internal energy will change. That depends upon the conditions. Work is done on by the system. So work done means if this gas pushes the piston up, then we say that work is done by the system. Work is done by the gas. Or when external pressure is more, and when external pressure is more, if the piston is pushed inside, that means decrease in the volume, then also internal energy can change. That depends upon the conditions. So when some more gas is added, that means matter enters or leaves the system. When some matter, that means when some gas is introduced into the cylinder, then internal energy can change. When some gas is taken out from the cylinder, then internal energy can change. So it is an extensive property. Internal energy is an extensive property. Extensive property means already in the previous video we have discussed what is meant by extensive property. Extensive property means the property that depends upon the mass of the system. So depends on mass of system. The property that depends upon the mass of the system or quantity of matter present in the system, then that is called as an extensive property. Extensive properties are additive in nature. Additive means they can be added. Next, it is a state function. So already it is discussed what is meant by state function or what is meant by state property. State property means depends upon only initial and final state of the system. So the property that depends on only initial and final state of system, but does not depend upon the path of the system. It does not depend upon the path of the system. Then that is called as a state function. So internal energy is extensive property and state property or state function. So this thing you need to remember. So it is impossible to determine or calculate the exact internal energy of a system. What is that? It is difficult or it is impossible to calculate the exact internal energy of a system. But we can find out the change in the internal energy. So what is change in internal energy? Change in internal energy is represented by change in internal energy is equal to change. Change means finite change means delta. Internal energy is represented by U. So change in internal energy is represented by delta U. Delta U means U final minus U initial. That means final internal energy of the system minus initial internal energy of the system. So that is a change in internal energy. So you can determine the change in internal energy, but you cannot determine the exact value of internal energy of a system. So internal energy, change in internal energy at constant volume. For example, let us take this gas is enclosed in a cylinder and it is screwed on both sides. So it is screwed. See, screws are there. We have screwed it. So when you screw it, automatically this piston cannot move up and down. When the system cannot move up and down, this volume of the system remains same. Volume remains same. Volume does not change. If volume does not change, then delta V is equal to 0. When delta V is equal to 0, then change in internal energy is given by QV. So Q means amount of heat energy at constant volume. This V represents that it is at constant volume. So change in internal energy is given by heat energy at constant volume. So that is what he represented here. So coming to internal energy of a chemical reaction is determined in bomb calorimeter. So there is an instrument called as bomb calorimeter. In that bomb calorimeter, we will be able to calculate the delta U, change in internal energy. This you will learn in the next part of the session, in the next video. And for a chemical reaction, so for a chemical reaction, reactants gives rise to products. This is chemical reaction. So reactants possess some internal energy and the products possess internal energy. Then delta U can be calculated as internal energy of the products minus internal energy of the reactants. For example, A plus B gives rise to C plus D. So here A and B are reactants and C and D are products. Then what is the, for this chemical reaction, then what is the change in the internal energy? Change in internal energy is given by internal energy of C and D, sum of the internal energies of, so internal energy of C plus internal energy of D, sum of the internal energy of the products minus internal energy of A and internal energy of B, sum of the internal energy of the reactants. So in that way, change in the internal energy can be calculated for a chemical reaction. So for an exothermic reaction, an internal energy is given by internal energy of the products minus internal energy of the reactants. So if internal energy of reactants is greater than internal energy of the products, then what you get? Delta U gives you reactants is greater, products is less, then we get negative value. If it is negative, it is understood that it is a exothermic reaction, exothermic process. Then if internal energy of the reactants is less than internal energy of the products, then what is delta U? Delta U will be positive. Then what is that? Then that represents that it is a endothermic process. Okay. So that is about internal energy. The main things what you need to remember: it is an extensive property, it is state function, then internal energy change at constant volume. You take volume of the gas constant, then internal energy change is given by heat energy involved at constant volume. For a reaction, internal energy change is given by internal energy of the products minus internal energy of the reactants. So that is about internal energy. Next, coming to heat and work. Speaking about heat and work. So heat and work are the modes of transfer of energy. If energy is transferred, then we can consider the heat and work as the modes of transfer of energy and not the form of the energy. That means they are not the forms of energies, but they are the modes of transfer of energy. Energy can be transferred in the form of heat, energy can be transferred in the form of work. So they exist only when energy is exchanged. So a transfer of energy to or from a system by the means other than heat transfer, then that will be called as work. If energy is not transferred in the form of heat, then we say that heat is transferred in the form of work. So these two are the modes of transfer of energy. So they cross the boundary of the system when the system undergoes change. When the system undergoes change, or when there is something change in the surroundings, then automatically there will be transfer of energy, and that transfer of energy will be in the form of heat and work. Then heat flows from one system to another because of difference in the temperature. And already we know that when two bodies are in contact, and if their temperatures are different, then heat always flows from higher body temperature to lower body temperature. So let us take here there is a system, gas enclosed, and this wall, or already we have discussed about what is meant by boundary. If this boundary is allowing the heat to flow, diathermic wall or diathermic boundary, then Q can enter into the system. That means heat can enter into the system or heat can flow out to the system. When heat enters into the system, then we say that Q is taken as positive. When heat leaves the system, then Q is taken as a negative. So when heat energy enters into the system from the surrounding, then the conventional sign is Q is taken as positive. When heat leaves the system, then Q is taken as a negative. And these units to measure heat energy or work is calorie or joule. And we know that 1 calorie is equal to 4.18 joule. Then we are coming to work. So what is work done? Work is said to be done when a resultant force displaces a body in its direction. For example, there is a body here. Now there is some force, resultant force, which is also called as unbalanced force. This force is pushing the body up to here. Now it has moved through a distance of, for example, d. Then the work done by that force is given by F into d. So what is meant by work done? When some resultant force or unbalanced force pushes a body in its direction and displaces the body through a displacement of d, then the work done is given by F into d or F into S if you take it as yes. So this is what mechanical energy. Here we are speaking about the work done, mechanical work done, or we can also say that it is PV work done, P into V. So work done, what are the units? F into D or S. We know that F is equal to MA into displacement. MA mass, M into acceleration is S by T square into S. So work done is equal to M into S square by T square. That means mass in SI system kg into meter square by second square. Let us go with PV work done. We are saying that PV work done. So what will be what we get the units on multiplying pressure and volume? P into V. So that is equal to pressure. We know that pressure is equal to force per unit area into volume. What is pressure? Force per unit area is pressure into volume. So F by A into volume. Into volume means volume can be written as area into displacement. Area gets cancelled. Then what you get? F into S. Again we are getting F into S. F into S, F into S. That means P into V will have the units of F into S. So P into V is having the units of work done. So work done can also be represented in the form of P into V. So that is called as PV work done. Work done. PV work done. So let us consider a gas in a cylinder. Let us consider a gas in a cylinder. Now this gas is pushing the piston. There is some external pressure. If external pressure P external is greater than pressure of the gas, P is pressure of the gas, P external is the pressure which is pushing the piston. If P external pressure is greater than pressure of the gas, automatically what happens? There will be compression of the gas. The piston moves into the cylinder and the volume decreases. Let us consider the piston is moving through a displacement of L or D, whatever it is. Then force is in this direction, movement of piston is also in the same direction. Then due to this force, work is done. So we know that pressure is equal to force per unit area. Force is equal to pressure into area. So work done can be, already we have written the formula for work done. So work done is given by force into displacement. So this force is can be written as P, and this pressure, what is that pressure? External pressure, not P, it is P external into S. P external into F is equal to P external into A. So P into A into S. So S is nothing but the displacement made by the force. So I can write P external into A into this L. Area into length gives you volume. So I can write that P external into, so area into volume gives you volume, change in the volume, a small change in the volume, because here is first initial volume, after that the volume is less, then this becomes the change in the volume. So I can write it as delta V, change in the volume is written as delta V. So work done is given by, what is the formula? So we are using minus P external into delta V. So delta V is change in the volume. I can write it is minus P external into V final minus V initial. So why did we write minus? To match to our convention. So sign. So for example, according to first law of thermodynamics, let us take gas enclosed in a cylinder. If work is done by the system means it is pushing. If work is done by the system means expansion. So work is done by the system, expansion means work is done by the system means negative side. Work done on the system, that means compression. So W will be positive. So if work is done by the system, according to conventional sign proposed, W is taken to be negative. When work is done on the system, W is taken as a positive. So now here it is compression. In this compression, V final will be less and V initial is more. Okay, this is compression. When it is being compressed, what happens? Final volume will be less, initial volume will be more. Less minus more gives you negative. This is compression. During compression, work done must be positive. If it is to be positive, then we have to use minus here. Here, less, more, less minus more gives you negative value. Negative into negative gives you positive. So for that, matching the conventional sign, what we are doing, we are using minus here. So finally, what you need to remember, work done is given by the formula minus P external into delta V. Okay. So conventional signs, once again we shall say, when heat is absorbed by the system, then Q is taken to be negative, positive. When heat is leaving the system, released by the system, then Q is to be taken as a negative. If work is done on the system, that means compression, work is taken as positive, and work is done by the system. That means if the gas molecules are pushing the piston and it is expanding, during expansion work is taken as a negative. Understood? So that is about the work done. Next, coming to first law of thermodynamics. Coming to first law of thermodynamics. According to first law of thermodynamics, the net energy change in a closed system is equal to heat absorbed plus work done by the system. So for example, this is the system. If the system is, in the system there is gas, in the system there is gas. In the system there is gas, for example. So these gas molecules possess some energy. These gas molecules possess some energy. Already we have seen that U internal energy, U initial. Okay. So now it has absorbed some heat energy. After absorbing some heat energy, it has done some work. It has done some work. So after absorbing some heat energy and after doing some work, what happens? There will be some change in this internal energy. Let us take that final internal energy after absorbing Q amount of heat energy and after doing some work. Let the final internal energy be UF. And we know that delta U is equal to final internal energy minus initial internal energy. So what first law of thermodynamics says that? It says about the law of conservation of energy. Energy is neither created nor destroyed, but one form of energy is converted into another form of energy. See, so this change in the internal energy, the other way of speaking about the first law of thermodynamics, this change in the internal energy is equal to the sum of the heat energy is absorbed plus work done. So what is this? Delta U is equal to Q plus W. The change in the internal energy in the system is equal to heat energy plus work done. So it describes about the law of conservation of energy. It has absorbed some energy, it has done some work. So the total change here will be equal to this sum. So this equation represents the first law of thermodynamics. First law of thermodynamics. So let us consider, and already we have understood that the formula to calculate the work done is equal to minus P external into delta V. For example, if delta V is equal to 0, that means volume is remaining constant. If volume is remaining constant, if delta V is equal to 0, automatically W becomes 0, because W is equal to P external into 0. Anything into 0 gives you 0. So work done will be equal to 0. If work done is equal to 0, then what you get? Delta U will be equal to Q. If it is not doing any work, then the change in the internal energy is nothing but the amount of heat energy absorbed. Here Q is positive, right? The Q is positive, then delta U is also positive. So positive delta U means increase in internal energy. Negative delta U means decrease in internal energy. So it is absorbing some heat energy, so that internal energy increases. So when it absorbs heat and if it is not doing any work, So when delta V is equal to 0, delta V is equal to 0. Delta V is equal to 0 represents that it is isochoric process. What process? Isochoric process. So in isochoric process, whatever the heat is absorbed by the system, that will be used to increase the internal energy. Next, coming to in this equation, if Q is equal to 0, Q is equal to 0 means it is not absorbing heat energy, not losing heat. So when Q is equal to 0 represents that what type of process? Adiabatic process. Adiabatic process. Q is equal to 0, adiabatic process. When Q is equal to 0, automatically delta U is equal to W. So W is positive, delta U positive. When is W positive? W positive means compression. See, when you are compressing it, pushing it, then automatically delta U positive. That means there is increase in the internal energy. So when work is done on the system, then there will be increase in the internal energy. Then it can also be written as minus delta U is equal to minus W. That means when work is done by the system, then there will be decrease in the internal energy. So that is about what adiabatic process. Okay. So this is what according to first law of thermodynamics. What first law of thermodynamics says? First law of thermodynamics says that law of conservation of energy. The change in the internal energy is the sum of heat and work done. Right? Let us take if delta U is equal to 0. Delta isothermal process. What is that process? Isothermal process. Iso means same. Thermal. Thermal means temperature. So delta, when temperature is constant in isothermal process, what happens? Delta U is equal to 0. When delta U is equal to 0, 0, if you apply in first of thermodynamics, 0 is equal to Q plus W. Then what will happen? Q is equal to minus W. What? Q is positive, W is negative. What does the present? Whenever some heat is absorbed, if there is no change in the internal energy, then what happens? Work is done by the system. That heat energy is used to do work. Or if let us take minus Q is equal to W. W is positive and Q is negative. Then what does that represent? If some work is done on the system, then some amount of heat energy is released. If there is no change in the internal energy, there is no change in the internal energy. So this is about the first law of thermodynamics. So there is another definition for first law of thermodynamics. What is the definition? The definition is that it is impossible to construct a perpetual machine. What is meant by perpetual machine? The machine that works without any interference. The machine, the perpetual motion machine, that means perpetual means which is working continuously, of first kind that work without consuming any form of energy. He says that without consuming any form of energy, it is impossible to construct a machine which can work. This is another way of discussing first law of thermodynamics. What is that? It is impossible to construct a perpetual motion machine of first kind that can work without consuming any form of energy. The other way of saying this first law of thermodynamics is law of conservation of energy. What is that? Net energy change in a closed system is equal to heat absorbed plus work done by the system. So the mathematical representation of the first law is delta U is equal to Q plus W. So these all things already we have discussed. So that is about the first law of thermodynamics. So if you like the video, please like, share and subscribe the video and click on bell icon so that you will receive notifications when I upload new videos. Thank you for watching up to the end of this video. Thank you very much once again.